This is the F8U-2N, an advanced version of the F8U-2 with a limited all-weather capability. The radar system and cruise relief autopilot let you concentrate on completing the mission you are flying. In this film, you will see how the F8U-2N differs from the previous F8U series airplanes. The external appearance is similar to the other F8Us. On the right forward fuselage under the missile mounts, there are two pneumatic pressure gauges which indicate pressure in the 375 and 1100 cubic inch air bottles. Ventral fins have been added to improve directional stability. As in the F8U-2, there is an air scoop on each side to provide additional cooling air for the afterburner. The F8U-2N may be equipped with single or dual pylons on each side, giving a capacity of as many as 4 Sidewinder missiles. There is no rocket pack. In its place is an additional fuel tank. This tank, the forward transfer cell, is part of the transfer fuel system. It delivers fuel by means of its own transfer pump to the main cell simultaneously with the other transfer cells. In case of a pump failure, fuel from this cell will gravity feed. The cockpit arrangement is very much like the F8U-2. After the initial cockpit checks, you're ready for external power. The on position is used for both external and normal power. A barber pole indication is seen until the main generator is in operation. Normal power comes from a 20 kVA AC generator, driven by a constant speed drive mounted on the nose of the engine. This generator supplies 115-volt, three-phase power to the AC buses. It also feeds a transformer rectifier. This takes the place of a DC generator by converting AC power to DC. DC power is supplied from the transformer rectifier to the DC buses. The emergency power package is identical to the F8U-1 package, ram air-driven, with separate AC and DC generators and a hydraulic pump. The checkoff list is now complete, and you're ready to start the engine. Starting procedures and cautions are the same as for the F8U-1. The 2N has a more powerful engine, the J57P20, which develops 10,700 pounds military thrust and 18,000 pounds maximum thrust. The idle is slightly higher, 68 to 70% RPM. After completing the ground checks, you're ready for takeoff. The military takeoff run is longer due to the increased weight of the F8U-2N. If afterburner is used, the takeoff run is the same as for the F8U-2. When you are trimmed and steady in the climb to altitude with the airplane in the clean condition, the automatic pilot can be engaged. Turn the autopilot normal mode switch to on. Press the engage-disengage button. The engage light will glow. The autopilot is now flying the plane in the normal mode of operation, maintaining the aircraft at constant attitude. When the wings are within 5 degrees of level, the heading hold function also engages. Control is now being provided in both heading and attitude. To change heading, use the bank control knob. Banking the aircraft more than 5 degrees disconnects the heading hold. The autopilot puts the plane into a banked turn. The displacement from center controls the amount of bank up to a maximum of 78 degrees. As you approach the desired heading, center the knob. When the wings are again within 5 degrees of level, the heading hold function re-engages and maintains the new heading of the airplane. The heading hold function can be disengaged in case the compass becomes inoperative or when the gyro is precessing. In normal operation, it is always left on. In the normal mode, the autopilot provides roll control and pitch control. The roll synchronizer and displacement gyro sense any change from wings level attitude and feed a correction through the roll amplifier in the stabilization section to the roll actuator, which controls aileron position. When you turn the bank control knob, a new reference roll attitude is established in the roll synchronizer. The system causes the ailerons to move until the plane is banked the selected amount. Then the ailerons are neutralized. When you recenter the bank control knob, opposite aileron is applied until the wings are again level. The MA1 compass gyro and the heading synchronizer act together to detect and correct deviations from the reference direction. Pitch control is similar. The pitch synchronizer and the displacement gyro sense deviations in pitch. A rate gyro damps the rate of pitch change. Minor changes in pitch attitude can be made with the pitch trim wheel. For level flight, disengage the autopilot, level off, and retrim. Then re-engage. Place the altitude hold switch to engage. The autopilot is now maintaining the airplane on constant heading and altitude. The altitude hold is achieved by means of the altitude controller. In this unit, altitude at the time you engage altitude hold is established as a reference. Any change from the reference altitude is sensed by the altitude controller. 2 electronic bleed-off circuits permit slow return to the basic trim settings when the autopilot is disengaged, and slow return to pitch attitude when altitude hold is disengaged. To avoid the buildup of excessive bleed-off errors, the pitch trim wheel should not be used while in the altitude hold mode. In either autopilot mode, never override the autopilot with the control stick, except in an emergency. After an emergency maneuver, disengage the autopilot, fly back to the original heading and attitude, and re-engage the autopilot. This is necessary to prevent the autopilot from returning you abruptly to the original heading and attitude. When you go into a level turn on autopilot, particularly at supersonic speeds, your altimeter may show a loss of altitude of several hundred feet. The autopilot uses a separate static source, which is sensitive to angle of attack changes and is therefore more accurate. It will hold you level in the turn. After rollout, the altimeter will return to the correct reading. However, at lower speeds, the altitude hold function loses accuracy and becomes sensitive to airspeed. As airspeed is reduced, the autopilot tends to lose altitude. To minimize this effect, the minimum recommended orbit or holding speed is 240 knots. Another characteristic of this autopilot is that a trim change, such as caused by a change in configuration or airspeed, will cause the autopilot to change altitude a few hundred feet. It is not necessary to correct for this change. In the F8U-2N, when you go into afterburner, a signal from the fuel control resets the engine to run at a higher RPM, with a corresponding increase of 30 to 40 degrees in turbine outlet temperature. To permit flying in certain adverse weather conditions, the F8U-2N is provided with an engine anti-icing system. Hot air from the diffuser section of the engine is passed through the inlet guide vanes and struts to prevent the formation of ice. Indicator lights glow as a warning when the system is on, since performance of the airplane is slightly reduced. When you are flying an intercept mission in the F8U-2N, the probability of success is substantially increased due to the improved APQ-83, which is a full tracking radar. Permit the radar to warm up in standby for 3 to 5 minutes. Put the clutter limiting switch in normal. Put the scan switch in normal to obtain the full search pattern. Turn on the fire control system. When the range switch is in the radar position, the fire control computer receives target range information from the radar. Set up the armament panel, in this case selecting the left-hand upper missile. Set the radar power switch to normal. Check the radar mode switch in normal. To adjust the scope, first tilt the antenna up using the tilt control thumb wheel on the radar control stick. Set the brilliance. Then set the gain. Restore the antenna to horizontal. The tilt mark indicates the antenna tilt position. The artificial horizon permits you to concentrate on the scope during the intercept and still maintain your attitude orientation. To check the system performance, press the test button. The number of targets displayed in this test varies from set to set. If the number of test targets is fewer than normal for this set, performance is not at peak. To check lock-on sensitivity, lock on to the smallest test target. This provides a check of range tracker and receiver performance. The radar is now operating properly in the search mode. GCI vectors you to the target. When you arrive within radar range of the target, if it does not appear on the scope, tilt the antenna up and down slowly until you locate the target. Antenna tilt position is critical on this radar. If the target is expected from one side, the radar can be shifted to scan on that side. This concentrates the radar search in the most likely detection area. In normal, the radar scans 45 degrees on each side of heading. When the target appears, adjust the tilt until the blip is painted by both sweeps of the two-bar scan. To acquire the target, move the hand control until the acquisition circle is centered over the target. To lock on, depress and hold the acquisition switch. The radar enters the acquisition mode. The range strobe sweeps a 2-mile sector until it strikes the target. Then the target light comes on, indicating that the radar is locked on the target, and the scope changes to the tracking presentation. If you have been flying in autopilot, disengage it. In the track mode, the course steering circle and the fine steering dot indicate the position of the target from you. This target is above you and to the right. Target range and maximum missile range are displayed to the same scale on the narrow B scan. Climb until the calibrated vertical, or tail, reaches the artificial horizon line. The target is now in the correct position above you, within the altitude differential that the missile can handle. When the target is in the missile envelope, the in-envelope light comes on. Pull up toward the target until the fine steering dot is centered in the course steering circle. Be sure to keep the steering dot centered so that the missile can acquire the target. Listen for the change in missile tone that indicates missile IR lock-on. Then fire. Mission accomplished and homeward bound. With its autopilot and advanced radar system, the F8U-2N is a powerful all-weather fighter, an effective weapon of the Navy's air arm.